1, negative 6, and 18. Yeah, we better get this one. Okay, so this is how you do an imaginary 0 through synthetic division. So coefficient 1, negative 6, 18 in order. Notice I did not change its sign because it did not have an X on it. All right, you bring down the 1, then you multiply. But because there's two pieces to this imaginary number, it distributes. So, but times 1, of course, doesn't change it any. So just bring over 3 plus 3i, both of those times 1. And then you add. Now when you add, you'll add your real parts together and get negative 3 and bring down your I part, plus 3i. Now this is what really slows this down. To times this by this, you're going to have to FOIL it, right? Because it's a binomial times a binomial. So I won't be able to do that in my head. I'll have to write that down and show the FOIL method. First, outer, outer, inner, inner, and last times last. Notice I'm hitting one of those I squareds. When you have an I squared, that changes it to a negative 1 multiplier, making that negative 9. The 9i and minus 9i cancel. Negative 9 and negative 9 is negative 18. So then when you add it down, it was a 0. If you get a 0 remainder, that means this k value is a 0 of this polynomial. That one of this. It's not a real x-intercept, by the way. It wouldn't show up on the graph, but you would have accounted for one of its solutions. Actually, there's a theorem, and I'll go ahead and mention it for the next section that we're going to do, that says anytime you find an imaginary 0, its conjugate has to also be a 0. So if we did this process again with 3 minus 3i, that's the conjugate, it will also give you a 0 remainder. So those are your two solutions to that. So it had no real x-intercepts. All right? Anyway, that's the conjugate theorem. It says anytime you have an imaginary 0, came out with a 0 remainder, then it is a guarantee that the conjugate of that, which just means change the sign in the middle, will also give you a 0 remainder. So two solutions, two imaginary solutions. It was a quadratic, so you've accounted for its solving now. No real x-intercepts. Hey, and we know this graph, it's a parabola, it's an upright parabola, maybe something like that. No x-intercepts, right? But upright because it's positive. All right, any questions on that? You see anything else on 3.2 homework?
Probably no fractions in this stuff.
Just little fractions add your to. So you may have some fractions to do. All right, so I'm going to go ahead and have you look at your notes again. We're going to talk about 3.3. It kind of continues this discussion on synthetic division and adds in a little extra application. All right, so notice 3.3 says the factor theorem. Again, with these theorems, and it's very important. X minus k is a factor of the polynomial p of f or f of x if and only if f of k is a 0 from your synthetic division. All right, so we've kind of talked about this, alluded to this in the graphing application for this. When you find a 0, you've really found a factor, something that goes into that evenly, and you've helped to factor it down so that you can find its x-intercepts. So that's what this theorem is really saying. If x minus k is a factor of your polynomial, if and only if, whenever you plug in f of k, you get a 0 remainder. That makes it a factor. And that's what we're kind of hunting for. So example 1, it says, is x minus 1 a factor of this polynomial? F of x equals 2x4 plus 3x squared minus 5x plus 7. And so really this is a yes-no question. You know, some of your questions are fill in the remainder, some are fill in the division answer. This one is a yes or no question. So if you get 3 tries, you got these, right? But I hope you'll be sincere and get the work out of this. But anyway, we're trying to decide if x minus 1 is a factor of that. So it's got the x attached, so we will change the sign to positive 1 and do our synthetic division thing. So changing the sign, then using all your coefficients, 2, it skips x3, so we need 0, 3, -5, and 7. And then go through your little synthetic division thing, bring down the 2, multiply, add. Say what?
No, I was just talking about.
Okay, we get a remainder of 7, so that means say no. If you get a remainder other than 0, it is not a factor, so the answer is no. Example 2, notice that the remainder is 0, so I've said yes. So that's what you'll see the first type of questions in 3-3. Just doing your synthetic division thing, and then yes or no if it's a factor. All right, so look at on down to example 3. This is the next thing you'll do. Then once you've figured out if you got a factor, you found a factor and it came out 0, then we can use that to go on and factor some more. So on example 3, it says factor into linear factors. So factor it all the way that you can. So if we were asked to factor that, and I had to do that just guessing thing, like the first example I did, I used x plus 6, and I kind of just, that came out of the sky. So if I had to just guess and try to find one of the zeros, that might take me a little while, but you might do it eventually. You could find it, and we'll have some clues to how we can guess. But most of the time in your homework, they'll give you something to start with. So notice the directions say, given that -3 is a 0. So they gave that to us. Given that -3 is a 0. So that will help me get rolling on this so I can get the first factor found. So -3 does not have an x on it, so use it as it is. Then take your coefficients, 6, 19, 2, and -3. Do your synthetic division thing to it, expecting a 0. If you don't, then there's probably a mistake somewhere, so look back through it. But I was expecting this remainder 0 because it told me that in the direction. Now, the directions have said factor it into linear factors, so it wasn't all the way factored. So what we've got so far is x plus 3. Remember when you put an x on it, it changes its sign. So that is x plus 3. This is down 1 degree, so that's 6x squared, 1x minus 1. So it's partially factored, right? It said to factor it into linear factors, which means this evidently factors all the way, or it wouldn't have said to do that. So now we're down to that old stuff we used to do, is unfoiling our quadratic. So then we try to figure out what works. 3x times 2x, plus and minus. I'm thinking 1 times 1, that gives me 2x minus 3x. I've got the wrong sign there. So check that out. -2x plus 3x is 1x. Negative times positive is -1. Completely factored, and that's a great thing. Now I can find all the x-intercepts and graph this thing totally. All right, so any questions on that? Okay, let's look at the next page. How are we doing on time?
You have 11 minutes left, but you have 10 minutes left on here.
Next page. These rules may be helpful if you're given a polynomial to factor and have been given no clues to the zeros. So, like I said, most of your homework will give you a clue, like this says -3 is a 0, but say you have no clue, you might have a problem or two like this. It says every time you find a 0, you move down 1 in degree. That's what we've been doing here. Once we did -3 work to be 0, I was able to take it from a cubed to a square. Takes it down 1 degree because we're always dividing by an x to the first. This x is assumed to be x to the first that we're dividing by linear factors. So that's what's taking it down 1 degree. Once you have a quadratic, and that's where they'll always be able to take us in the clues or through some of our strategies, get it down to a quadratic, then we've got it made. We know how to solve quadratics with the formula if necessary. All right, the P over Q rule. P over Q rule says any rational 0 of a polynomial will be found by taking the factors of the constant divided by factors of the leading coefficient. So instead of that just guessing, finding a number in the sky thing, a good guess would be the P over Q rule, which says factors of the constant, that's the P, divided by factors of the leading coefficient. Divide those out, but that's a good thing to at least try. So what are factors of 3? That's your P. And factors of 6, that's your Q, called the P divided by Q rule. And it's the factors of 3, so that's positive and negative 1 goes into 3, and positive and negative 3 goes into 3. So things that go into 3. Divided by things that go into 6 evenly. So 1 works for everything, right? You're always going to see 1 goes into everything. 2 and 3. And 6, right. So, I mean, I know it's not the greatest thing in the world. There's still a lot of numbers there, but it does at least give you a list to go through. 1 divided by 1 would be 1. Negative 1 divided by negative 1 would be positive 1. And then if it was a positive divided by negative. Anyway, when you get down to it, it's a positive and negative of that as well. So you've got to try positive and negative 1. The positive and negative of all of these are possibilities. Then 3 divided by 1. 1 divided by 2, that's a half. 1 divided by 3. 1 divided by 6. 3 divided by 1, I already did that. 3 over 2. 3 over 3 is 1, I've already got that. 3 over 6 is a half, I already have that. Let's put this up here, 3 over 2. And positive and negative of all of those. So that would be the set of all the combinations of factors of the constant divided by factors of the leading coefficient. Then I would start just trying through that list. Notice negative 3 worked. We got that. That would actually have been on the list, right? So if they hadn't given us that clue, we could have found it eventually, right? And once you find one of those zeros, that took it down to x squared, and we could find the other 2 ourselves. But that's, I think you have a question in your homework where it says list all the possible rational zeros. That's what you have to do on that question. Yeah. And then hunt for one that works. If it asks you to factor it, you have to start through that list until you find a 0 on the end, and then factor from there. All right, let's see what else is in this section. The boundedness theorem, we kind of mentioned this earlier too, says if you divide by a positive k value out here, and all of the stuff under it is positive, that means search no further that way. All right, if you've got all positive numbers in your line under it, that means that you need to look no further on the positive side. And on the flip side, if it is a negative number like this one, if you divide by a negative k value and these signs alternate, look no further on the negative side. So that didn't happen here. We had positive, positive, negative. It has to be positive, negative, positive, negative. Alternating signs, and 0 counts either way. Then look no further on the negative direction.
So if that 6 had been a negative, we wouldn't have had to...
Right, then I know not to try negative 4 or negative 5. Or negative 6. Did I have anything that way? I don't know that I had any choices, but right. Let's do another one with an imaginary in it. Anybody have a particular one from your